Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to explain how velocity time graphs work and how you can read them and how you can get information out of them. They look like this. We have time on the horizontal axis and we have velocity on the vertical axis. And I will now go in depth to see what information you can get from these graphs. First we start with this graph. As we can see here, we have a constant velocity of 12 meters per second. So at the beginning of the movement at time 0, we already have a velocity of 12 meters per second, and of course at the end also 12 meters per second. So we have a constant velocity, and we can determine the displacement from this movement. So we can determine the displacement between time is 0, so here, till time is 15 seconds. And we do that by getting first the information out of the graph. So we know that the velocity is 12 meters per second and it's constant. So it doesn't matter where on the time we look, it's always 12 meters per second. And we know the time, or the total time, which is 15 seconds, because we start from 0 and we end at 15. Now, to calculate the displacement, delta x, we need to rebuild this equation. So we need this one, we need the 6. So 2 times 3, so the velocity times the time. So it will look like this. So to calculate the displacement, we multiply the velocity with the time. So 12, because that's the velocity, times 15, because that's the time, and we have a distance of, a displacement of 180 meters. So during those 15 seconds, this motion had a displacement of 180 meters. Now we have a different kind of motion. As you can see, the velocity is not constant anymore. It's starting at 0, it's ending at 21, and it's increasing with a constant acceleration. So we have a constant acceleration here. And again, we have to determine the displacement between time is 0 and time is 15. Now it's a little bit different. We have the initial velocity, which is 0 meters per second, and we have the final velocity, which is 21 meters per second. We also have the time, 15 seconds. And to calculate the displacement, we again need to rebuild this equation with this one I use as a trick. So we now need the average velocity. We have a beginning, an initial velocity, we have a final velocity, and we need an average velocity. And we can calculate it with this equation. So we have the initial velocity plus the final velocity divided by 2. And then we have the average velocity. And this is something you can do when we have a constant acceleration or a constant deceleration. So now we add these into the equation. So we have 0 plus 21 divided by 2. This is always 2, and it's an average velocity of 10.5 seconds. So 10.5 is just in the middle of 0 and 21. So that's the average velocity is 10.5 meters per second. We add it into this equation, 10.5 multiplied by 15 because it was 15 seconds, and now we have the distance, or sorry, the displacement, which is 157.5 meters. The same can be done with this movement. As you can see now, the velocity is decreasing, and it's decreasing with a constant speed. So we have a constant deceleration. It starts at 20 meters per second, it ends at 5 meters per second, and again from this movement we have to determine the displacement. So first we get the initial velocity, which is 20 meters per second. The final velocity is 5 meters per second, that's over here, and we have the time, which goes from 0 to 15, so that's 15 seconds. We have this equation which we have to rebuild, so we need to do 2 times 3, so the velocity time multiplied by the time looks like this, and again we need the average velocity, and this one works the same as the previous one. We have a straight line here, so we can add the initial plus the final velocity and divide it by 2. So it looks exactly the same, and now it just goes lower, but it doesn't matter. So we have 20 for the initial velocity, 5 for the final velocity, divided by 2 is an average velocity of 12.5 meters per second. And if you will see, it will be in the middle of the 20 and the 5 we already have here. So now we have the average velocity, multiply it by the time, and we have a displacement of 187.5 meters. And this is the last example. We now have the velocity, which is increasing, but it's not increasing with a constant acceleration. As you can see, the acceleration itself is also increasing, and therefore the velocity is not increasing in a straight line. And this is a problem because we now cannot use the previous equation with the initial velocity plus the final velocity divided by 2. To get the average velocity from this graph, we have to make an educational guess. It's somewhere here. You can check that by looking at the area which is over here, and it has to be roughly the same area which is over here. So if these two areas are the same, then you are roughly at the average velocity. When you have such a question, you can always have a small margin of error. In this case it was 4.2, so probably between 4 and 4.4 would have been correct. So you can make a small error, but you have to look for the area above the line here, which has to be roughly the same as the area here, and then you have the average velocity. So with such lines, the only thing you can do is make an educational guess. So in this case, the average velocity is 4.2 meters per second. The time is 15 seconds. We start at 0, we end at 15. We use this equation. We have to rebuild it again, so we have to get the 6 with the 2 times 3. So delta x is the displacement is the average velocity times the time. 4.2 average velocity multiplied by 15, and we have then a displacement of 63 meters. Now an example you can try yourself. We have here a motion, and we have to determine the displacement of the entire motion given in the graph, and we will split it into 4 areas: area A, B, C and D. And try now for yourself to see if you can determine all these displacements and then add them together to have the total displacement. So try for yourself. I will now give the answers. We have these 4 areas. We will start with area A. The line is not straight, so we have to make an educational guess, and it's somewhere 4 seconds. That's not educational guess, that's of course what you can read, but the average velocity is somewhere here. And again, this area is roughly the same as this area, so it's around 1.2. If you would have gone between 1.4 meters per second, it would probably already have been correct, but 1.2 is the best one now, and of course the other one would also have been correct, because again, you can have a small margin of error. So now we have the average velocity, we have the time, so we multiply them, and we get a displacement of 4.8 meters. So during those first 4 seconds, the displacement was 4.8 meters. So we can put it there. And now we go for B. B is a lot easier because we have a velocity which starts at 3 meters per second and ends at 3 meters per second. We have a time which starts at 4 seconds and ends at 7 seconds. So the initial velocity, 3 meters per second. Final velocity is the same. The time 7, because that's where it ended, minus 4, so that's 3 seconds. We can multiply them because we already have the average velocity, which is just 3 meters per second, so we use that. Multiplied by the time, and we have 9 meters. So the displacement during B was 9 meters. We added over here. Now we go to C. C, we have an initial velocity of 3 meters per second. That's over here. It ends here with 0 meters per second, so that's the final velocity. The time, it ends at 13, it started at 7, so that's 6 seconds. The average velocity between those two we have to calculate, so we use this equation again. We add 3 plus 0 divided by 2, so that's 1.5 meters per second. We put it in the equation here, 1.5 multiplied by the 6 seconds, and we have a displacement of 9 meters. So we put that down here. The last one. Now we go to a negative velocity because it goes below the 0. So we have an initial velocity of 0, it starts here, and we have a final velocity of minus 1.5. So we put in a minus here. We have a time, it ends at 16, it begins at 13, so it's 3 seconds. We have to use the average velocity, so we first have to calculate the average velocity by using this equation. We add 0 plus minus 1.5 divided by 2 is minus 0.75 meters per second. We put it in the equation, multiply it by the time, and we have the displacement of minus 2.25 meters, and we put it here. So now we have all the individual displacement, and we can add them together to get the total displacement. So we add them all together, and the total displacement of this entire motion is 20.55 meters. That's it. You should now know how velocity time graphs work and how you can get information out of it. If you found this video helpful, please let me know by liking it, and of course subscribe for more videos. Thanks for watching.